Hello, everyone. Welcome back to our YouTube channel, Becoming a ROS Developer. My name is Rodrigo, and today we have a student presentation from one of our online courses, ROS2 Navigation in 5 days. At the end of this course, you can take a project and actually apply it on a real robot. So that is what we're going to be seeing here today from our student, Stefan. Hello, Stefan, how are you?
Hello, I'm great. Thank you.
Awesome. Well, I'm excited to see your presentation, Stefan. So whenever you want, you can start sharing your screen and show us what you've done with navigation here. Hello? It seems like we might have a connection issue. It seems so. Oh, Stefan, are you there?
Yes, I'm here.
Hi. It seems like we had a connection issue for a little bit. Great. Let me see if
Right.
we're back on. Yes, great.
Right. So this is my screen.
Uh huh.
It's showing. It's all right.
Yes, it is showing. Yes.
All right. So this is the robot. Here I have the RVs opened and some sheds. I will start the nav to stack. So the map is loaded. All right. And here I have the spot list, which is empty, and we'll record 3 spots,
Uh huh.
and then we'll make the robot go through them. So here I have the service launch used for the spot recorder. We launched it, and let's begin with this spot in which the robot is. I have the service with a state, uh, which tells when to begin. And now I have the 2 lines in the spot list
Right.
for the ROS parameters.
Mm-hmm.
After that, we'll add a label. So the state now is add, and the label is corner 1
Right.
for the first spot. And the coordinates are saved. After that,
So are
let's
you
try and
sure
move the robot.
I'm sorry, if we look at your RViz, are you running
Yes.
localization now? Because it,
Ah,
it seems like you need
my
a
my bad, my bad. Yes,
uh-huh.
yes, yes. Exactly.
There we go. Yes. I think
All
that
right.
was why
Yeah.
that said
Yes, yes,
0.
yes. All right. So now the robot is centered on the map. Um, let's try that again. So the begin, and now the spot list has started, and the corner. Yes, that's better. All right, and now we'll move the robot to the second corner. We'll make it this one.
Mm-hmm.
All right, so we'll put this to be corner 2, and it's saved. And
Great.
after that, we'll go to the pedestrian.
Awesome. While you get there, let me just summarize for the audience what you're doing here is you are
Yes,
saving 3 spots uh,
yes,
that the
exactly.
robot will then know where they are to then use nav 2 to go to those places.
Exactly. And this is the pedestrian. And
Awesome.
now we have these two. Let's close the service. All right. And now we have the spot node. And let's go to corner one. And now the path is made. And the robot is
Mm-hmm.
going to the first corner. After that, we'll go to corner two. And also the path is computed. The robot is moving.
Mm-hmm.
All right. And back to pedestrian. All right. So the
Awesome. And
it reached pedestrian. So this is the program functionality.
mm-hmm.
Now
Very
I
clear.
have
Nice.
a PowerPoint presentation. All right.
Awesome. We see your presentation now.
So the objectives of the project are to save the spots. For that, I use MCL post topic subscription and spot saver service. The second objective is to move the robots to the safe spots. And for that, we have to read the data from the spot list file, search the spot name parameter in locations from file, and use the navigate to pose action client. And the third objective is to launch all the navigation to stacks. For the spot saver, like I said, I use the MCL post topic subscription
Mm-hmm.
uh, to find the coordinates, which are the position and the orientation, position X, Y, and the orientation Z. Uh, the second from the spot saver is the spot saver service, which I created and saves the specific coordinates when called, saves them in the spot list file, labels the data with the requested parameter, and format the file for ROS parameter.
Mm-hmm.
For the robot navigation, we read the data from the spot list file, which are the corner one, corner two, and pedestrians. Uh, we search the spot name parameter in locations from file. We label we search the label of the desired objective for the robot, and this is given in the run command. And we use the navigation to pose action client to set the goal pose in accordance with the objective from save spots. And for navigation launcher, the nav to stack, we launch the map server, MCL, planner server, controller server, PT navigator, recovery server, and the lifecycle manager. And in the lifecycle manager, of course, the node names parameter has the specific nodes in the same order like in this file.
Mm-hmm.
And with map server, we load the map. With the AMCL is used for robot localization. The planner server computes the path with the map obstacles. The controller server is used for the dynamic obstacles. The BT navigator, behavior tree navigator, coordinates the navigation uh, and its behavior, and the recovery server executes the recovery behavior. So That's it in short.
That's it.
Yes.
Awesome. Yes, great. Let me give you a round of applause here. Congratulations, Stefan. Really, really nice. A
Thank you.
couple of things I liked, and a couple of questions too. Uh, so, really like how the spot recording is done through ROS parameters. I'm not sure if that's a requirement, but that's how you should do it. So I really like that. And
Thank you.
your cost maps, for example, looked really finely tuned. But let me ask you about those cost maps, because usually um, here in this remote robot connection, sometimes we have some issues about RVIS's ability to display the cost maps. Let me ask you, have you had this issue? And if so,
Yes.
how did you solve that?
Well, with a question on the community.
Can you quickly just go over how you did that?
Uh, yes.
Because I think it's very
So
useful.
there I found out that in all the config files for the path planning,
Yes.
I have to change the used sim time to
Uh
false
huh.
with small f, and in wait a second to find it, and in the launch file to false with a big F.
Is that
So
really
all
how
the
it solved? It got solved.
yes, yes,
That's incredible, actually. So
yes,
uh,
exactly.
we should actually create a an issue on the official Arvis, because this is a little bug, I believe, because it
Yes,
shouldn't be like this.
I think so.
Because all right, great. Because I think it's very useful to always see your cost maps to know what the robot is doing. And I
Yes,
noticed,
exactly.
you made the path really thick. Uh,
And
I yes.
besides that, I had a problem with the robot model in RVs.
Uh huh.
Uh,
Oh yes, I can see that. Yeah, yeah, yeah. Usually that's
in
something that we just leave off, but yeah, I see
yes, in
that.
simulation it worked, but with the real robot it showed nothing.
Right, and
So
that's in the topic, right? You're providing it.
yes, I provided a topic but didn't work. So I found here in the uh, code editor, I found in the simulation the URDF file.
Mm-hmm.
So I
Yes.
loaded it as a file. So everything's great.
Ah, okay. So you instead of doing it as a topic of robot description, you loaded it as a file.
Yes, because as a topic, I didn't find the solution.
Right, right. Maybe we're not even publishing the robot
Yes,
description
it's
actually.
possible.
So awesome. Um, let me see what else I wrote here. Yes. Well, I would say, um, just to let you know, to avoid that first issue that that you had, that you believed it was localized but it wasn't, you can actually set a silly, a dummy
Yes, yes,
initial
yes, yes.
pose. Uh,
Yes, I
s-
know.
s-
Actually, yes, I think I missed it somewhere, but I have rebuilt the map in this morning because
uh-huh.
the signs
They
are
move, yes.
yes moving, and I obviously changed
The
uh,
starting spot.
the starting spot exactly.
Yes, because that is where the map frame gets
Yes,
published. So that's a good thing you mentioned. Uh, it helps you a lot with, where do I start creating the map, things like that for
yes,
later
yes, yes.
use. Um, awesome. And yes, you can also actually call a service in AMCL, which is called global localization. And if you don't want to set the initial post, if it might be really
So
wrong in your application, you can do that, and it just spreads out the AMCL particles. That's another good tip. And
yes,
the last thing I noticed was that your node, that where your action client it abruptly it dies, right? When the goal is reached, it dies, correct?
Mm, I think so. Yes.
Right, because you can maybe just my suggestion is handling that because it's maybe it was an interrupt where you pressed Control C, uh, but maybe you want to like raise a flag or return a success that you can use that later for your code instead of
All
like
right.
an abrupt death of that node because it might have weird behaviors later.
All right.
Uh,
Yes.
But other than that, I was really impressed how straightforward your demo was and how clear it
Okay.
was that what you were doing and saving it, and that the robot had no issues arriving to the goals. So, congratulations, Stefan.
Thank you very much.
All right, guys. So, I'm going to go back here to my screen and let you guys know that you can do what Stefan did here in order to get one of our certificates. That is to complete our online courses and then do the project that is in there that you're going to apply on a real robot. So I invite everyone that is watching to do what Stefan did here. That's it for us, guys, today. We hope to see you again soon. All right, guys. Bye bye.